Here's an interesting trigonometric equation that you might maybe encounter if you're preparing for the maths high level IB, especially if you're trying to push yourself a bit further. So this involves sine to the power 4 of x plus cosine x cubed equals 1. Okay? And this sort of looks like the more familiar equation that everyone should know, which is sine squared plus cosine squared of x equals 1, right? But in our case, the equation looks a bit different as opposed to the identity, which is always true, okay? So let's see how we would do this. First of all, the good thing is that the argument is the same in both cases. Okay, so we have x, we don't have sine of x and cosine of 2x or anything like that. So the arguments are the same in both terms, but we have two different functions. So the first one is a sine and the second one is a cosine. So let's maybe try to convert one into the other. Okay, and for that we're actually going to use the identity that I wrote earlier. So we can actually do it in two ways. We can either say sine squared of x is 1 minus cosine squared of x, or we can write it as cosine squared of x equals 1 minus sine squared of x. So technically either of those two substitutions work. Now we just have to figure out which one works better in our case. So if we use the second one, so if we replace the cosine with, well, if we replace the cosine with the square root of this, then we're going to end up with a square root, right? Because this is cosine cubed. So cosine cubed is essentially cosine squared multiplied by cosine, and while we can replace cosine squared with 1 minus sine squared, then we have to deal with this, which is going to be a square root, and it's going to get more messy. So let's actually do it the other way around. So let's substitute sine squared of x with 1 minus cosine squared. So I'm going to go here, and instead of sine to the power 4, I'm going to write it as sine squared of x squared plus cosine cubed of x, and this equals 1. Okay, so sine squared of x, instead of that, I'm just going to write 1 minus cosine squared of x squared plus cosine cubed of x, and that's equal to 1. Okay, so let's expand the first bracket, and if we do that, we're going to get 1 minus 2 cosine squared of x plus cosine to the power 4 of x, and then we're going to have plus cosine cubed of x equals 1. Okay, so it looks like we ended up with a quartic equation. So we can actually see that the 1 cancels out, which is nice, because now we just end up with cosines in every term. Okay, so if I rearrange this, I'm going to get cosine to the power 4 of x plus cosine to the power 3 of x, and then minus 2 cosine squared of x, and this whole thing is now equal to 0. Okay, so what we can do now is obviously factorize a cosine squared. So we have cosine squared of x times, and then we have cosine squared of x plus cosine of x minus 2, and this is equal to 0. So now we have two cases that we have to look at separately. Okay, the first one is the fact that cosine squared might be equal to 0, right? Because when you have two things like this, which multiply together and the result is 0, it means either of them is equal to 0. So in the first case, we have cosine squared of x equals 0. So that's a solution, but now we have to find out what x should be, okay? So cosine squared of x is 0, which means that cosine of x is 0, which means that x, so this has the usual expression, which I'm going to write on a different page. So essentially, if cosine of x is equal to, let's say, a, okay, and we're just dealing with real numbers here, by the way, so everything is a real number, then x is going to be equal to, we have plus or minus arc cosine of a plus 2k pi. Okay, so this is the general expression which gives you the x when you know that cosine of x is equal to a. Okay, so as you know, there's an infinite number of solutions because this function cosine is periodic. Okay, so if we use this here, this is going to be plus or minus arc cosine of 0 plus 2k pi. Okay, so x is going to be equal to, so now we're thinking, okay, what's arc cosine of 0? So you can use a calculator if you want at this point, or you can ask yourself the cosine of what angle is 0. Okay, and the answer would be, so we have plus minus pi over 2, plus 2k pi. Okay, because cosine of pi over 2 is actually 0, and arc cosine of 0 is pi over 2. And that is not just one solution, it's more like one set of solutions. Okay, so x is plus or minus pi over 2 plus 2k pi. Right, now we have to deal with the second case, which happens when this is equal to 0. So let's write it here. In the second case, we've got cosine squared of x, and then we have plus cosine of x minus 2 is equal to 0. So this is actually a quadratic equation, which we can, just for simplicity, let's substitute cosine of x and let's turn that into a t maybe. So we have t squared plus t minus 2 is equal to 0, and then we can find the discriminant, which is 1 plus 8, and it's 9. So t12 is minus 1 plus minus square root of 9, which is 3 over 2. So as usual, we have two solutions. Well, we have two solutions because this is positive. Okay, so the first one is minus 2, and the second one is 3 minus 1 over 2, 1. Okay, now you should notice at this point that this is not actually a valid solution, because t is actually equal to cosine of x, and this has to be between minus 1 and 1. Okay, and minus 2 is not in that interval, so it's not a proper real solution. So this is the only one we're going to look at. Okay, so now the question is, what is x when cosine of x is equal to 1? And the answer is, as previously mentioned, it's going to be plus or minus arc cosine of 1 plus 2k pi. Okay, and we know that this thing is actually equal to 0, so this just turns into 2k pi. Okay, so now we have to put everything together, because we have two sets of solutions that both satisfy this original equation here. So the first one is of the form, so let's actually write it like this. X is part of this set, okay, which is a reunion of two different sets. So the first one is plus or minus pi over 2 plus 2k pi, where k is an integer, okay, and then we have a reunion with another set which is 2. Now this is still k, but it can be a different integer compared to this one, so let's write it as L maybe. So 2L times pi, where L is an integer. Okay, and that's it. So x, as long as x has either of those forms, then it is a solution to this original equation. And that's the end of the question.